Okay, before we get started, any questions, comments, feedback? If you didn't see my comment on Slack, based on your DMs, I've updated the class roll, but a number of you still have some missing classes, so you either want to watch those and let me know, or you've already watched them. Let me know. I did post what I currently have out on Slack, so you can see what's recorded. And that'll ding you. It's basically minus 2% for each missed class, which you either didn't attend or didn't watch the video of. So get that done. Yes?
For the demos next week, just to set expectations for like how we're supposed to demo, are we gonna just be able to like show our computer to everyone, or like kind of what's the expectation?
Yeah, that's actually, we'll launch into that in a second,
okay.
Because I do want to talk about that. Yes?
For watching the videos to make up for missing class, is there like a deadline for that?
I usually put the deadline, well, a good deadline is the midterm. I think for actual grade purposes, the deadline is like the last day of class, which is, I think, December 8th, or whatever.
Yeah, I'm planning on doing it. I just didn't know if I
Yeah.
missed it already.
No, you're fine.
Okay.
I would recommend it if you've missed classes, it's probably a good idea to watch them before the midterm itself. Other questions, comments? Since the issue came up, demos. Next week's are demos. Boy, they don't have any white markers in here.
There's one behind you.
Oh, there's one. What we'll do is, as you come into class next week, you can just list your project there. So if you want to get done first, you can write your project name up there. If you don't want to, then you can wait till everyone else writes their project. So make sure that they're, in case you're doing some last-minute coding. And remind me, we'll talk about what it's like to do demos at trade shows, because I've been there multiple times, both as someone who's doing the demo and as someone who's watching demos. The 3 to 5 minutes. Probably want 2 people. What you're going to do is you're going to come in, make sure that you have a device that can hook up to an HDMI cable, because that's what we have to project up here. It was actually easier over the last 2 semesters with Zoom, because people would just bring it up on the screen. The HDMI can be, we've had times in the past where people have tried to plug in devices and it hasn't worked and so on. So just make sure whatever you're demoing on, it has an HDMI port, because you'll just come up here, plug it in. Typically, it's useful to have 2 people run the demo, one to give a 60-second reminder of here's what we did and here's what we've accomplished, and then spend a minute or 2 demonstrating what you've got. How long you spend depends on how much you actually have to show, which I've already had some discussions with you. It's like, oh, here's a static image. So that's basically how the demos will work, and we'll have lectures. We'll do the demos right off the bat. We'll finish up Facts and Fallacies next week, and we'll finish up Webster 6. We're going to do some of Webster 6 today, just to get some of it out of the way. And Facts and Fallacies 3 we'll get through very quickly. So I expect us to be out of here by 3 today. Other questions about the demos? And by the way, you get credit simply for showing up and doing a demo. I don't worry about how much I think you should have had done. I don't look at your code. I don't care about your code. This is a quick and dirty project. Your code can be as ugly as you want. Any other questions or comments before we dive into this? Someone please remind me when I'm done covering as much as I'm going to cover in Webster 6, we will take roll in. And then we'll do the Facts and Fallacies, and then we'll be out of here. Okay, Webster 6. 25 years ago, I wrote a book. After my time at Pages, I wrote a book called Pitfalls of Object-Oriented Development, which sort of summarized everything I wish I'd known 5 years earlier. It came out at the same time as the original Design Patterns book, and actually one of the Design Patterns authors said he wished he'd known I was writing this because there's some stuff that he wanted to incorporate in there and vice versa. But what I've found over the years is that the first 3 chapters in particular are pretty much universal to any software project. I've posted these lists before, and I've had people say things like, I could talk about all of these with regards to, say, agile methodology, or DevOps, or you know, a particular programming language. So this is, as I said last week in talking about the midterm review, this page, which is a single web page that you can pull up while you're in the middle of your midterm, is a very useful cheat sheet. I've had students who literally have answered almost every question using pitfalls. You know, there's a few things they run out of, but frankly, it covers so much ground that there's a lot there you can mine. So if you're stuck, go to the pitfalls page, which is linked to on the class website. Just have it in the tab, look at it and say, oh, hey, yeah, that looks like that applies. And please read it, because if you misapply it, I will know, and you'll get docked for that. So let's talk about this. And I'm going to see if I can click through okay without any problems here. Oh, look at that, it came up.
No, it didn't. Not for us.
Oh, well, that's right. I'm sorry. I've got to, hang on. I've got to basically get out of, come here. There we go. And when I wrote this, I actually modeled my book after one. It was a Macintosh programming book, and I forget what it was, but I really liked it because what it did is every single item was on 2 facing pages. So I wrote these deliberately to be short, and the actual physical book, which you can still buy on Amazon from old stockpiles, every pitfall is on 2 facing pages. So you open up the given pitfall and you see everything right there. Followed a identical pattern here. The using the wrong developers, we've already talked about how people matter most. And here the issue really is the differences in productivity, in skills, in TEPIS basically. Talent, experience, professionalism, education, skills. And if you try to develop a project and you have the wrong set of developers, the project will have serious problems. It may fail. If you have an excellent set of developers, particularly if you can mold them into a team, it almost does not matter what technology, what domain, what methodology, what you're using, they will find a way to get it done. I've seen that time and again. Your best software engineers will simply work together, figure stuff out, and will apply, in particular, their experience. There was a time with TEPIS where I had education as the first E and experience as the second E. And as I spent more and more time reviewing failed projects, I actually decided the experience was more important. Because it's that ability to be on a project and say, wait, I know how this ends. It's like, no, we've got to do this, this, and this because I've already been on this project and this went down a rat hole. This is what we need to do. And of course, then you get into the how do you convince everyone else. So this is sort of an obvious one. But a project, if you're using the wrong developers, your project is already behind the 8 ball. Any questions, comments, observations? I mean, this is something we've talked about almost every class. Okay, let's hang on a second. Oh, I'm trying to figure out why don't I have the back arrow there, because I clicked off here. Okay, control click. We've talked about metrics. You had a three-part article, lies, damn lies, and metrics. So if you're focused with the wrong metrics, it's not going to help. If you're saying my metric is, the number of lines of code per day delta, that's one of the worst metrics of all time, because to a certain extent it's meaningless and code encourages code bloat. It does not allow for refactoring and re-architecting, and it's largely irrelevant. So most metrics, most commonly used metrics really are at best neutral and at worst misleading. So you want to, if you're going to use metrics at all, they have to be metrics that matter. As I've already mentioned at Pages, the metric that was the single most predictive and useful one was actually during our glide path to ship, and that was the number of, let's see, number of new bugs. Number of new bugs opened over the number of bugs closed. And any time that was greater than 1, it meant we were basically finding more bugs than we were fixing. So we tried to get that as close to 0 as we could. And of course, you don't have any new bugs at all, then it really is 0. Actually, I'm going to, lying to yourself and others. This is sort of a combination of the inherent optimism. Dale Goldberg, only optimists build complex systems. We all tackle complex systems because we think we can do it. We think it's a simple matter of programming. We think that, yeah, we're behind and we can get caught up with 1 or 2 late nights or with a weekend of coding. And then you have managers. You have the thermocline of truth, where you tend to become less and less connected with reality as you move up the management chain. Oops. I'm sorry, that didn't show up with the right one. Did I link to the wrong one? Everyone's like, letting me talk with the wrong one up there. Thank you. Let's see here. Actually, hang on a second. I'm going to do this easier. I don't need slides. Go to here. There we go. There's the line to yourself and others. Part of the issue here is drinking the Kool-Aid about the new technology or methodology, thinking that Agile or DevOps or Go or Swift or microservices or containers or whatever nifty new, AWS, whatever nifty new technology, methodology, language, whatever, is going to solve your problems. No, it's not. And you need to stay realistic and stay grounded and realize the realities of software engineering will always apply. There are no silver bullets. There are no miracle cures. It's always complex. It is always difficult, unless you're simply doing the same thing over and over again, at which point you're not doing anything of value. Any questions or comments here? You have to really watch this one, because you'll get managers who will just be raw and think it's going to solve things. Not identifying and managing risks. Now, when I wrote Pitfalls back in the mid-90s, there really weren't any risk management systems. A lot of systems now, I think SharePoint has one built in, some of the other development environments have explicit software for identifying and managing risks. And some of the most successful software projects I've seen have been ones that have been very proactive on this. They say, here's the risk, and with given risk, you have both the probability of it happening and the impact if it happens. So if you have a high risk but low impact, it's like, yeah, whatever, we'll deal with it. If it's a very low risk but a very high impact, it's like, okay, we need to be prepared if we have to handle this. In some cases, it's high probability, high impact. I've actually been in projects where I've identified risks and said, look, I think I have told you this, but I'll tell you it again in this context. My first consulting job, I was brought in to help the Motorola Iridium project get back on track and worked on that. But in the meantime, they were starting a new project for a different customer. And about the time we were actually delivering our next build on the Motorola Iridium project, I went to a meeting to kick off this new project. And they said, okay, you know, this was like the start of November. Said we're going to start coding, start of December, we'll be done coding. Start of March, we'll have a month of testing, and then we'll deliver. Does everyone sign up for this? And everyone around the table, they got to me, I said, no, I don't sign up for this. I said, we have no architecture. I said, we are waiting on a 1.0 release of a development environment that no one here has used before. You know, you've all had a week of training on it, but it's a 1.0 release of a compiler. Imagine what that's like. I said, you know, we don't have an architecture, we don't have anything. We don't even have a full set of requirements. And after the meeting, I went back to my desk and typed up an email and sent it out to all the managers and upper management, identifying 13 risks. Said, here are the risks that I see here. And I was told, shut up and architect. Well, about 2 months later, I literally pulled up that email and sent it around to the same group and pointed out that 12 of the 13 risks I had identified, had come to pass. And we were slipping. We were slipping like multiple days for each day. And the project continued to slip, and they decided that was probably in start of February. Start of April, they said, well, we really don't need you here anymore as a consultant. I had a nice farewell lunch with the vice president of the division. And he says, I know we butted heads sometimes, and, you know, but I appreciate any feedback you had. I said, part of that is just, you know, that's the nature of the beast. You know, I'm a consultant, I'm saying outside things. That you should not have ignored that risks email. Said, the problem is that you look either stupid or dishonest or both to your customer, who's a major telecom firm. I still had contact with some of the developers there, and within 2 or 3 months after I left, the entire project had been canceled. It slipped so much. The delivery date had slipped. By the time I left in April, the delivery date had slipped to September. It continued to slip, and finally the customer, MCI, said, no, you guys aren't getting anywhere here. You have to aggressively identify and manage risks and not and especially, you don't want to look like an idiot to your customer. Any questions or comments? Yes?
I'm just wondering, what are some examples of risks? Like, could you maybe define that a little bit?
You know, it's somewhere buried in my archives. And it's probably using Eudora mail client at the time. I'm sure on a disk somewhere. I still have that email. Someday I'm going to have to go through and try and find it. But some of the risks I recall, no architecture. A 1.0, in fact, at that point, still the compiler, the development environment, which was ASN.1 on IBM workstations, still had not been released. No one on the team had ever delivered production code using ASN.1. So it's a brand new language. They've had 1 week of training on it earlier in September. 1.0 release of development environment. And I had already had my own experiences as doing developer technical support at Sun and finding bugs in compilers to know what a 1.0 compiler can look like. They're the insufficient testing, insufficient development time, not knowing enough about the project to even estimate the development time. And that stems from the fact that there's no architecture, there's no design. How do you say, yeah, it's going to take us 3 months to code? You don't know what you're building yet. Those are ones I can remember off the top of my head. I had like 30. And the only one that didn't come to pass was I identified as a risk, developers getting frustrated and leaving because of how badly the project was being set up and managed. And at the time, 2 months later, when I said that no one had left. Other than that, all the other risks, the other 12 risks all come to pass, and we're all negatively impacting the project. Okay. Adopting a technology or methodology without well-defined objectives. If you say, yeah, we're going to do DevOps and everything's going to be great, it's like, okay, do you actually have anyone who knows how to do this? I'm actually watching my daughter Crystal, as I mentioned, she changed jobs. The firm she worked for is a DevOps shop, and she was very nervous about going there because she didn't understand anything. She's already coming up to speed, but it's a very successful, well-run DevOps shop, and she is coming up to speed. What I've seen, and I've mentioned this before, I've seen projects that after the second or third slip suddenly adopt Agile, thinking this'll get us back on track. And it doesn't. They think it's a magic, they think it's a silver bullet. They don't know why they're adopting it. And usually, much as what I just described, no one has ever actually delivered production code using an Agile methodology. Or they think Agile is, yeah, we have a bunch of stuff on the board, we do standard meetings every morning. The question is, why are you adopting this? Are you adopting this language, this environment, this methodology, because of these specific benefits which you can successfully predict? Or is this a Hail Mary pass thinking this is somehow magically going to get this project back on track? Have any of you been on projects where you've seen them suddenly switch technology or methodology in an attempt to try and rescue things? Anyone? Anyone? It'll happen, trust me. Trust me. Okay, let's see here. Misjudging relative costs. Okay, we've already talked about this, and here my big point is mostly on SQA. Companies almost always underestimate the amount of time testing is going to take and the resources. You know, Brooks says 50% glass, and I think we may talk about that today, covering chapter 3. It says 40%, but it's a whole lot more because most companies think it's like 5 to 10%. You know, we're back to Larry Spellhog saying, can't we just get some college students to type on pages and for a few weeks and that'll be our QA? It's like, no, it's not how software quality works. And again, to Larry's credit, he listened to me. We hired a director of quality and had a full-time professional QA group, which was absolutely essential. And a lot of the delay in shipping was because things that we thought we knew how to do, we're discovering our unknown unknowns, and it was taking a long time to get the bugs out, because when you have something like desktop publishing, where people are using it in a highly interactive mode and then printing it, errors just basically are tolerated. Except I still deal with errors in Microsoft Word. That's a whole other question. Any questions or comments on this? Allowing new features to creep or pour in. This is scope creep. This is so well known. I shouldn't need to say more here. And I'm sure most of you I've seen projects where it's like, okay, yeah, well, we got this done. Let's do this. Let's do this. Let's add this. Can't you add this? And this is where you need to really be hard-nosed, because some of the features they tell you, it's one of those, yeah, I can do that in probably 20 minutes. You know, I just have to do this, and do this, and do this. And sometimes you're right, and sometimes you're wrong in that. But the problem is that they'll come back and say, okay, here's this feature. It's like, well, no, that'll take about 3 months, and they won't believe you, and they'll add it anyway. Or, as we've already talked about, having the director of marketing come back and say, oh yeah, I sold 300 copies of this, but we have to add these 3 features. And you're like, that'll take a year. You're not talking about minor features. You're talking about major revisions to the program. Said, oh no, we said we're going to deliver this in 2 months, and we have to have these 3 features. Scope creep is one of the biggest problems in software development, particularly where you have a disconnect. It's less it's less of a problem in commercial software development. If you're, as I've already said, and as all of you have probably experienced, when you're developing for something that you're planning to put out in a market or whatever, you end up dropping features. It's kind of like, yeah, if we're trying to make this date, we're not going to get this done. So you start dropping features left and right. When you're in a corporate or government setting, and you've got management saying, we want this and need this, that's where you start to get a lot of features just sort of flooding in from various parts of the company, and you have to really put your foot down and say, no, we can't do that, or you have to give us this much more money and this much more time. Any questions on that one? Allowing the specification or drift to change without agreement. This is particularly something I see in a lot of two-party or three-party software projects. You want to make sure both parties are very crystal clear on what the actual requirements are. Because otherwise, you have interpretations that can differ. You know, your customer says, oh, it has to do X, and you say, okay, we're making it do X. And the two of you actually have quite different ideas as to what X are. Or the customer says, oh, X also includes Y and Z. And if you're not careful, that may go through, and you're saying, wait a second, we never agreed to Y and Z. Well, yeah, that's part of X. You have to do this. You want a control over requirements, and any way the specification changes, it should be in a reduction, not an addition, in my opinion. Your mileage may vary. Attempting too much, too fast, too soon. Oh, yes.
Sorry, I was just with the with like differentiating between scope creep and then like changing specifications. Is scope creep kind of more just, hey, like we'll just keep adding these things, versus the specifications is like, well, we actually didn't do a great job of communicating what we're agreeing to do.
Yeah, and you're right that those two are very similar, but the drift is more what the actual definition of what you've agreed on. In other words, scope creep is we're adding new stuff. You know, A, B, C, D, E. The drift is, we said A, yeah, we agreed to A, but suddenly A here starts changing and sort of expanding, or it turns out to be something quite different from what you thought. You've been solving the wrong problem for 6 months. And you said, oh no, we actually need to do this. It's like, you never told us that. Attempting too much, too fast, too soon. This is true in adopting any new technology or methodology. I've seen so many troubled or failed projects where they, and it goes actually all the way back to the one I just told you about, my first consulting job, where you have a time-critical project that's using a brand new technology no one's ever used before. If you're adopting a new technology or new methodology, do a trial project. Get comfortable with it. Discover what works and what doesn't. Most companies don't want to spend the time or effort to do that, and the irony is they do anyway, because if they simply mandate it for the project, again, with this first consulting project, it was supposed to be done in February, then it was going to be done in April, then it was going to be done in June, then it was going to be done in September, and then it got canceled. And all because they were trying to, they bid this whole thing, this multi-million-dollar, national network management for MCI, and they were basing it on a technology they had never used before, literally. And a 1.0 release. It's not even like it was a mature technology they were simply adopting. It was a 1.0 release of a technology that no one had ever delivered production code before. Too many companies will see technologies or methodologies as silver bullets. What you want to do is do trial projects. And companies, generally speaking, aren't willing to do that. Abandoning good software engineering projects. There is often, and when I wrote this, remember when I did the Inside Out SQA, it was because there was a vice president at Fannie Mae who thought, oh, we're using object technology, we don't need to do testing. And I was like, are you nuts? But often with methodologies, with technologies, people will say, oh yeah, we don't need to worry about that anymore. We can cut corners on this. the core principles of software engineering have been around for 50 or 60 years for a reason. They are close to eternal verities. The problems remain the same. The core issues remain the same. As I've already said before here, and as I frequently say online, part of my frustration about how little people in the industry read is that they not only keep reinventing the tire, they keep reinventing the flat tire. And they do. They do. They reinvent the flat tire. It's like, you know, I was seeing project failures like this 40 years ago. And you think, you think somehow magically this isn't going to apply to you. So you want to continue to be rigorous with your software engineering regardless. Okay, that's as much as we're, any other questions? That's as much as we're going to cover today on this one, on Webster 6. But I think you can see how these may be useful during the midterm. Hey, it's a freak point. Great movie. How many of you watched it? Hey, look at that. We're getting some comments. History is made at night. Character is what you are in the dark. That was also the inscription in one of my books. Okay, and I always forget this, that we only covered part of chapter 2 last week. So, maintenance. Maintenance is so interesting. Glass says it's probably the most, and maintenance, we tend to think of, oh, this is some old legacy program. No, maintenance is what happens after you ship 1.0. You're maintaining your software. You're continuing to fix bugs and add features. And it can actually be a problem. When I was at Fannie Mae, one of the problems they had is the percentage of their IT budget devoted to maintenance was growing steadily, and it was going to consume their entire IT budget within about 4 or 5 years. And this is part of the reason why they had OSG in there, and they're trying to find a way to do a lot of re-engineering and reduce some of their maintenance costs. As it says here, large organizations can spend 50–80% on their entire budget on maintaining existing systems. But, and I like this quote, old hardware becomes obsolete. Old software goes into production every night. One of the cases I'm working on has to do with insurance software that was written in COBOL back in the 1990s. And it's millions of lines of COBOL code, a lot of which I've looked at. So old software hangs around for a long time. As I've mentioned before, the Y2K, the Y2K issue back in, one of the great things Y2K did was it allowed a lot of companies to kill off a lot of old software because they decided it was better to buy new software or to implement something new than simply try to fix or patch the old one, particularly when you no longer had source code for a lot of systems. And it forced a lot of companies to spend time updating their software, but that's been 20 years, so we have an entire generation's worth of new embedded software, and embedded, I don't mean in terms of embedded devices, stuff that is entrenched in organizations and simply keeps getting revised more and more. Any questions on this one? How many of you have had jobs or internships where you've had to work on existing code that's already in production? Yeah, what's it like to try and they say, here's a list of bugs we need you to fix and or features to add. What's that experience been like for you? Anyone want to share? Yes.
Painful.
Yeah.
Like, there's, especially when you could tell that they just like really just tried to whip it together in the first place, and you're wondering why, if you could just like, I've had like bug fixes that turned into just having to refactor the code because it was just so bad.
Oh yeah.
It was just so much more realistic to just refactor it all instead of trying to fix it.
Technical debt is real, and maintenance almost always involves technical debt, and it can be hard to convince the company to say, yeah, we really need to refactor this. I already told the story at Apple. That's basically what I had to do. There's this big, ugly massive Pascal routine that I finally just said, "No, I'm going to rewrite the whole thing." And it came out, I reduced it by about 80%. Cleaned up all the bugs when I did that and was able to easily add features. But it was the ugliest Pascal I'd ever seen. Okay. Interesting figure here. Enhancement, adding new features, is about 60% of cost. Error correction is about roughly 20%. He says actually 17% fixing bugs, 18% adaptive maintenance. A friend of mine, Mike Godwin, said he was in a hospital and he happened to be looking at a monitor. He was visiting someone and happened to be looking at a monitor and the software had crashed and said they were running Windows XP. There is the installed base of older versions of Windows is actually bigger than most statistics reported indicate, because usually those systems, the statistics that you can get online that say, percentage, well, the one I cited, for example, Windows said, here's a percentage of systems that are running Windows 10, Windows 7, Windows 8, whatever, are based on internet surveys. And there's a tremendous number of embedded systems that never use a browser that are still running on Windows XP, and in some cases even earlier. The military is especially bad at having some really old, archaic software and spending lots and lots of money to Microsoft for support for systems that are still running on Windows NT or I suspect Windows 98 in some cases. So that's the adaptive maintenance, is changing it. Okay, I've got this program, it's been running on Windows XP, I've got to bring it up to Windows 10 or now Windows 11. Still not upgraded to Windows 11 yet? What are your thoughts on it? Anyone?
I thought it looked kind of nice and clean, but on Windows 10, I had my start menu all like nice and organized with everything, and Windows 11 just basically gets rid of all.
Why did they do that? Why did they do that? They've done that like 3 versions. We're going to make this go away. No! That's how I run programs. Idiots, yes.
Yeah, so I mean, I use Mac OS and I got Windows 11, and I think there's a lot of similarities, and it seems like they're trying to merge into more of how Mac OS is laid out.
Yeah. But that's not what people are used to. Any other comments? The reason I asked is because I got a little message at the bottom on this very laptop this morning that said, you can upgrade to Windows 11. I thought, oh, do I really want to go through this pain now? Yes?
So I upgraded to Windows 11, and I'm an AMD Ryzen user. So I was hit by the performance bug, which is now patched, fortunately.
Yeah.
But that was a little bit rough for about a month.
Yeah. Oh, God. Anyway, okay, sorry. Moving on. Preventive maintenance. This 8%. Preventive maintenance. No, 5%. Paying down technical debt. That should actually be a much bigger percentage. If you actually spent more time on preventive maintenance, you would make it easier both to add features and fix bugs. But companies don't see it that way. This is another problem, and I mentioned that much like SQA, maintenance is seen as sort of a problem area. It's like, this is where your benefits are. It's like, okay, we can reduce technical debt, we can improve performance, we can add features, we can fix defects, but it tends to be where the entry-level people get shunted off to. And one of the articles that I'm trying to think of, I think it's in the extra credit on having a maintenance architect. I actually think companies, if they had a maintenance architect, it'd be a great training ground for a chief architect, and it would actually reduce maintenance costs. So, but you've got maintenance. Now this is an interesting thought, and I hadn't thought of this. This actually gets back to your comment. When you're doing maintenance, you still go through everything, or at least should go through everything you go through in new software development, except you have to figure out how the software works. You don't have the advantage of starting with a clean slate. It's like there's all this existing code, which may or may not be well structured, which may have all sorts of idiosyncrasies in it. So you spend, and Glass says, you spend about 30% of your time just trying to figure out how the code works in the first place. So adding features to an existing system can actually be more costly than adding features to a system under development, because you have to deal with what's actually there. And there's my site and link to the maintenance architect. By the way, the slides are already up on the website. Better software engineering leads to more maintenance. In other words, the better you build a system, the longer it stays in production. If it's really bad, then you try to replace it sooner. Or at least you hope it is. And it's easier to modify if it's well designed, well architected. One of the great things about Pages, again, one of the things I'm proud about, is how we were able to release successive versions with major feature additions, because we had spent so much time up front on the architecture, the design, and frankly, the quality of the code. Any comments through any of this maintenance stuff? Quality. Jerry Weinberg says quality is something that is of value to some person. And that's important to remember how vague that is, because that's what you're going to deal with. You're going to find that for the different companies you work for and the different projects you work for, even within the same company, that the priority of quality attributes will vary. I've mentioned that I worked on space shuttle flight simulators. The space shuttle software that actually ran the space shuttles was designed to be of ultra-high reliability, because you don't want a software bug happening when you've got people in a brand new first generation spacecraft up there with lives on the line. Glass has his set of quality attributes. I have my preferred set. But it's really going to vary on the project and on what's important to the company. If you remember the Inside Out SQA thing, one of the issues are, one of the sets of inputs in your work is, what are the priorities for the company? What do they care about? Now Glass goes on, after listing reliability as a quality attribute, he goes on to the next item and says, quality is not reliability. I disagree entirely. Quality is very much tied to reliability. He seems a little incoherent here. I'm not sure what he's talking about, but my definition of reliability, carrying out its function without causing unacceptable errors or having unacceptable downtime, that is very much a quality issue. And in some respects, quality, the reliability, performance, and functionality are my big three, and of those three, reliability is the most important. You need to get the right behavior, the right answer. Any questions on these? More on reliability, which he has a whole section on after saying reliability wasn't a factor. There are errors that programmers tend to make. We all know them. You know, it's like the old classic, depending on your programming language, using assignment instead of testing for equality. And this was much more common in earlier languages. Then you have actual stuff that are deep probe errors that we tend to make. We tend to, this is why there's an eternal debate about should SQA be different from what programmers do. Should developers do all the testing? Or should you have a separate SQA group? And actually, I had strong debates with Chuck Knudsen about this, because he felt developers should do everything. I said, no, you need people who are going to do absolutely insane things to your software that no programmer would ever think of doing. And so you've got issues, errors that we tend to make, leaving something out, something we tend to be blind. This is why the debugging technique of explaining your bugs to someone else is so effective, because you get halfway through and suddenly your mind is going, uh-oh, I know what I did, and I'm going to look like an idiot when I explain it, so you ask the person to go away, and then you quietly fix it. Errors tend to cluster within errors. In other words, this is Pareto, your 80-20 rule. 80% of your errors tend to occur in 20% of your code. My personal opinion is that this is due to deferring hard problems. You actually tend to push your hard problems off to certain sections of code, and you get an 80% solution there. And then you come back to try and approach 100% completeness, and it suddenly gets very ugly and very complex. Any questions on these? There is no single best approach to error removal. I think that error removal is highly underappreciated as a software engineering skill. It's because what you have to do is you basically have to build the model of what's happening in your head and then figure out where to look. And we've got a lot of code. That's an issue. My two most important roles, in my opinion, at Pages were first chief architect and second chief bug fixer. Because I knew the entire set of code. You know, we had like 8 developers who all were working on different things, and I roamed freely through all 400,000 lines of code. And when a bug would happen, it's like, okay, I can think of 3 or 4 different places where this might be happening. Let's go in, let's put some traces, let's test for this. And I could track down bugs faster than anyone precisely because I knew all the code. Whereas if it's just you've got your chunk and you're trying to figure out a bug, it may be due to factors that are completely outside the code you're looking at and that you may not even have access to, depending on how your project is structured. All code ships with bugs. What you're trying to do is you're trying to reduce the severity of the bugs and decide what to live with. The Pages, we had our defect list. I think we shipped with 400 known bugs, which is actually minor compared to a lot of commercial software. But they were down to, okay, we know what it's going to take to fix this. This isn't a showstopper. This is an annoyance. This is a minor problem. There are obvious workarounds for the end user, and we will fix that in the next version. And we did work to continue to reduce our defects and our technical debt after shipping 1.0. But at some point, you just have to hold your nose and push it out the door. And it is important to distinguish, there we go, distinguish between the severity of the error and the likelihood of it occurring. You know? How many Windows users have ever had a blue screen of death? Okay. That's a total kernel panic. You know, total system crash. We've all lived with that. Those are all due to various defects and bugs in the Windows code. And yet Windows, you know, has a couple of billion copies floating out there somewhere. Efficiency, boy, this is a big issue. You've got the memory code trade-off. What do you do by pre-computing and using memory versus what do you do in code? You've got, you know, caching something versus fetching on demand. Don Knuth said, you know, premature optimization is the root of all evil. But at the same time, performance has to be designed in. So you have to be thinking about what your own number is going to be for different chunks of it. And I remember the first time I had already mentioned this, first time I ever used a profiler. And there was a profiler available for the code I was working on. And it's like, this is so cool. I see immediately where my code is spending all of its time. And I look at it and say, oh, look at that. I should move that out of that loop. So you want to design with coding in mind, and then you have the coding. There are lots of questions on Quora about, you know, should I learn assembly language? And the general answer is no, don't worry about it. There's, you know, unless you're doing embedded systems, there's really no point in dealing with assembly language. I was professional in an era where you had to deal with assembly language. Often that was the only environment you had to work with, or you know, the Fortran compiler was so slow, it's like, no, or so unable to access memory or hardware, whatever that you had to do assembly. Trade-offs between size and time. I think that's pretty much something all of you are aware of. Sometimes you can buy speed by using more memory, but sometimes you are far less memory constrained than I was in my time. Now I'm back doing coding on systems of 4K, 16K. Actually, I had some at Monitor Labs. We had some data acquisition devices where we had 256 bytes of RAM. You know, the code was all in ROM, but for actual data storage in real time, you had 256 bytes. So it was a different era. And that's the end of chapter 3. Okay, for next week, your last podcast is due this Saturday. I just extended the code review deadline. I saw about half of you missed it. Okay, you've got until Saturday. For those of you who are just doing it, you know, you got that. Because I'm more concerned that you do it than that it gets done today. You'll have a Steam status report due next Monday. We already talked about demos. We'll go through the midterm review again fairly quickly. We'll go through facts and fallacies. So next week is going to be a bit longer class. Just plan on that. Because we'll have the demos. Demos usually take, and we've only got, what, 7 projects? Yeah. Demos, so I suspect we'll get through the demos in about 45 minutes. And the lectures, the midterm review again will probably be about another 10 minutes, because we've already done that once, and then the stuff. So I imagine we'll probably be about an hour and a half next week, so plan on that. 2 weeks is midterm. Well, we'll talk more about that next week, but once again, it's all online, no class here. You'll have a 24-hour period, all of Monday from about 5 after midnight to 11:59 p.m. 3-hour timed, everything's open, note open, you know, everything open except your classmates. And I suspect, I'll have to go through and check, I suspect most of the grading is up to date, except possibly a few of the team status reports. And that's it. Are there any other questions before, let's look at that. 2.5-hour class, you're going to get that in 55 minutes. I told you I got better as you got later in the semester. And you know, next week will be a little long, then you'll have your midterm. Then the Monday after Christmas, or excuse me, Monday after Thanksgiving, will be out. Everyone panics then. Will be relatively short. That'll probably just be my legal issues lecture, so that'll actually be pretty quick. And then we'll have your final demos, and that's it. You guys have just all been great. Yes?
On your website, it says that this week we need to like update all of our deliverables.
That's for your own purpose. I'm not going to go back and relook at them. Yeah, everyone's like, no, that's you know, I'm just, like I said, I'm just trying to get you prepared for the real world. If no other questions, go have a great rest of the week, and I'll see you next Monday.